Namaskar everybody. Welcome to online refresher course in chemistry conducted by UGC MMTTC Pondicherry University, Pondicherry. Myself Ravikant Jaiswal, Assistant Professor of Chemistry in Government RNM College Bhadgaon, Chhattisgarh. Today I am discussing about Jablonsky diagram to understand phosphorescence and fluorescence. So, what is phosphorescence and fluorescence? We have seen that sometimes our currency note are checked in ultraviolet light by banks or some shopping complexes, and few things which are disappear in normal light get appeared in blue color. This is called fluorescence. And we have also seen some watch dials and sometimes glowing toys which glows in night. This phenomenon is called phosphorescence. So let us see what actually happens in molecular level. We know that there are two states or energy states of any electrons, that is ground state and excited state. Generally, all the electrons in a molecules are paired and stay in the lowest energy level at the given temperature, which is called ground energy level. Now, any light or any energy is given to them, or these electrons absorb certain kind of energy, certain type or certain amount of energy, and jump from their ground energy level to higher energy level, which is called excited state. Let us see what happens during this excited state. So, as you are able to see the diagram which is provided in left hand side of this slide, where in downside you can see there are two electrons present which are paired. One is upward direction and one is in downward direction. So these two electrons are paired and the total quantum number, that is total spin quantum number for them, is 0. Plus half plus minus half is equal to 0, and the multiplicity becomes 2s plus 1, that is 1. Therefore, any state where two electrons are in opposite spin is singlet state. So this is represented by S0. We can say this is singlet ground energy level. Now, after absorption of electron energy, one of the electron, which is shown in blue color, dark blue color, get excited. You can see there is no change in spin, just upward where S1 is written. You can see electron has been excited, but there is no change in its spin. So still the total spin quantum number is plus half and minus half is equal to 0, and the spin multiplicity remains 1. So all these excited states are called singlet excited state, S1, S2, S3, etc. You can see just besides the singlet excited state in between S0 and S1 on right hand side of the diagram, there is one more excited state, which is little lower, that is triplet state. Why? You can see the electron here, the spin of electron has changed. Now the two electrons, one in ground energy level, green colored, and one in excited energy level, T1, has the same spin. So the total spin quantum number becomes 1, and the multiplicity becomes 2s plus 1. 2 into 1 plus 1 is equal to 3. So these excited states are called triplet state. Triplet excited state T1, T2, T3, etc. So our electron has absorbed energy and jumped to different excited states, either in S1 or in T1. So now our excited electron wants to come back to its ground energy level because excited state is unstable state. So there are two types of methods by which it can come back to its ground energy level. One is non-radiative transition. So what happens in this non-radiative transition state? Electron in higher excited state first loses little energy in the form of heat, and it happens by two methods. Internal conversion, where electron moves from same type of higher excited state to same type of lower excited state, that is from S2 to S1, from S3 to S1, or from T2 to T1, like this. Next is intersystem crossing. In this type of excited state, electron moves from singlet state to triplet state. You can clearly see when electron comes from singlet state to triplet state, it changes its spin. Therefore, change of spin requires some extra energy. Therefore, corresponding triplet state is always in lower energy than that of same type of singlet energy state. Okay. Now there are next type, large transfer of energy or large loss of energy is caused by a radiative transition. Now radiative transition are also called luminescence because during these changes electron loses large amount of energy in comparison to non-radiative transition, and here the energy is released in terms of light rays or electromagnetic waves. Radiative transition is of two types, that is fluorescence and phosphorescence. Here in fluorescence, what happens? Electron from singlet excited state 1 comes back to singlet ground energy level, that is from S1 to S0. The time requires here is very less. It is about 10 to the power minus 8 seconds to 10 to the power minus 7 seconds. This type of material which show this phenomenon are also called fluorescent material, like highlighter of your pen, safety features in currency, which are visible in UV light. Next one is more interesting, phosphorescence. In this process, electrons return back to singlet ground state from triplet excited state number 1. So this transition requires more time because here again electron has to change its spin. Now this type of transition takes about 10 raised to the power minus 3 seconds to few minutes and sometimes few hours also. You can also see this type of phenomenon in watch dials, some paints, glow in dark toys and sticks are the example of phosphorescence. Thank you for today. Thank you very much.